Hello everyone, this is Dr. Manali Datta and welcome to my channel Chemistry with Manali. I hope all of you are doing very well. So in the previous two videos we have discussed about electronic configuration and valency of elements. So if you need a recap of the previous concepts, please refer to the videos, and today we will be proceeding with two major topics. The first one is in reference to the second video, that is valency of elements. So today I'll teach you a simple trick to predict valency of elements, and the next topic that we will go through is formation of compounds or bonding in compounds. Okay, so let us first go to trick to predict the valency. So here there are the elements from atomic number 1 to 10, and the stable or noble gases are marked here, that is helium and neon. So these are the electronic configuration of the elements, and the next column is the valency. So since the valency of hydrogen is 1 and the valency of lithium is also 1, so how to predict these valencies? So the electrons in the last shell of an element, these electrons, these are called the valence electrons. Okay, and the last shell is called the valence shell. So if the number of valence electrons is 1, 2, 3 and 4, then valency will also be 1, 2, 3 and 4. Okay, and if the number of valence electrons is more than 4, that is 5, 6 and 7, then you can predict the valency by subtracting 5, that is the number of valence electrons, from 8. Why? Because in this shell, L shell, the maximum number of electrons that can be accommodated is 8. So I repeat again, if the number of valence electrons is less than 4, then the valency will be equal to 1, 2, 3, 4. That means whatever is the number of valence electrons, that will be equal to the valency. And if the number of valence electrons is greater than 4, then you have to subtract the number of valence electrons from 8. For example, in case of nitrogen, the number of valence electron is 5. So when we subtract this number of valence electrons 5 from 8, we get this valency of 3. In case of oxygen, the number of valence electrons is 6. So we subtract this 6 from 8, so we get a valency of 2. And in case of fluorine, the number of valence electrons is 7. So we subtract this 7 from 8 and the valency is 1. So this is one simple trick to predict valency. You will have to consider only the valence electrons and see whether it is equal to or less than 4 or it is greater than 4. If it is equal to or less than 4, just write down whatever valence electron is present, that is equal to the valency, and if it is greater than 4, just subtract it from 8. So by using this simple trick, you can predict the valency of the elements.
3.
So now we will be proceeding with the next topic, formation of compounds. But before that, I would like to request each one of you, please post your doubts and queries in the comment section. I will take up all those doubts and come up with separate videos. Also, I would like to make a humble request to all of you to please like my videos, share them and subscribe to my channel, because it takes a lot of effort and encouragement to come up with these videos. So if you like and share my videos, so it will give me more encouragement and I'll come up with videos regularly. So this is a humble request to each one of you to please like and share my videos and subscribe to my channel. So now let us proceed to the topic. So formation of compounds. So after electronic configuration and valency, the next topic is how compounds are formed, how the electron exchange takes place between atoms to form a compound. For example, X plus Y, these two elements compound to form this molecule XY. Now how this molecule is formed, how does the electron exchange take place? This electron exchange takes place either through transfer of electrons from one atom to the other or by sharing of electrons. So this is what we will discuss here. Now compounds may be of two types. One is electrovalent or ionic compounds and the next one is covalent compounds. In case of ionic or electrovalent compounds, electrons are transferred from one atom to the other. For example, NaCl, sodium chloride. This is an example of ionic or electrovalent compound. Now, how this bond is formed? This bond between sodium and chlorine, how this bond is formed, that we will discuss. So, sodium atomic number is 11 and electronic configuration is 281. That means it has one electron in the valence shell. So, its nearest noble gas is neon. So, what it wants to leave this or donate this valence electron to attain the electronic configuration of the nearest noble gas, neon. Neon's electronic configuration is 28. So, sodium has a tendency to achieve the electronic configuration of neon, 28. So, it has a tendency to donate this one valence electron, and sodium is in search of such a species to whom it can donate this electron. Now, chlorine atomic number is 17, electronic configuration is 287. Now, the nearest noble gas of chlorine is argon, whose electronic configuration is 288. So, chlorine has a tendency to achieve the electronic configuration of argon. So, it is in search of such a species who can donate chlorine one electron. So, naturally sodium is one such species who is ready to donate this one electron. So, if chlorine bonds with sodium, it can easily attain this one electron from sodium and it can achieve the nearest noble gas configuration 288. This is the concept of the formation of ionic or electrovalent compounds. How the bond is actually formed. Sodium 281, it will lose this one electron to form positively charged species. When an atom loses electrons, it forms positively charged species called cations. Now, the electronic configuration of this cation is 28 because it has donated this valence electron. Now, chlorine, whose configuration is 287, chlorine will accept this electron which is donated by sodium. It has accepted this electron and it has formed this anion or negatively charged species, and its configuration is now 288. Why? Because it has accepted the electron that sodium has donated. So, now both are in a stable configuration. Sodium has attained the stable configuration of neon and chlorine has attained the stable configuration of argon. So, both are now stable. So, now what they will do, these two ionic species, the cation and the anion, they will be connected by electrostatic forces and they will form the ionic bond between them. So, this bond form is called the ionic or electrovalent bond, and the compound formed is called ionic or electrovalent compound. So, this is how the transfer of electron takes place from one atom to the other in case of ionic compounds. So, now we will move to the next type of compounds, that is the covalent compounds. So, in ionic compounds we have seen that electrons are transferred from one atom to the other. In case of covalent compounds, electrons will be shared between two atoms. Electrons will be shared equally between two atoms. For example, let us consider a compound hydrogen molecule. Here two hydrogen atoms are combined together to form this molecule. Now, the electronic configuration of hydrogen is 1 because its atomic number is 1. So, it has one electron in its valence shell. Similarly, for the other hydrogen atom also, it has one electron in its valence shell. Now, hydrogen has a tendency to achieve the electronic configuration of the nearest noble gas, which is helium. That means it has a tendency to accept one more electron to attain the configuration of 2, that is of the nearest noble gas helium. So, it is in search of a species who can either donate one electron or it can share one electron. So, in this case, what this hydrogen will do? It will share the electron of this hydrogen, and similarly this hydrogen will also share the electron of this hydrogen. As a result, what happens? This hydrogen is now having 2 electrons and this hydrogen is also now having 2 electrons. So both are stable now, both have attained the noble gas configuration of helium. So this is the covalent bond that is formed between them. This bond that is formed by the sharing of electrons between the two atoms is called the covalent bond, and the molecule is called a covalent molecule. Okay, now let us see another example. For example, oxygen. So atomic number of oxygen is 8. Its electronic configuration is 2.6. So it is in need of 2 electrons in its valence shell to attain the electronic configuration of the nearest noble gas, which is of neon. So oxygen is in search of such a species who can either donate 2 electrons or it can share 2 electrons with a species. So these are the 6 valence electrons, 1, 2, 3, 4, 5 and 6, and for this oxygen also 1, 2, 3, 4, 5, 6. So what this oxygen will do? It will share these 2 electrons of its nearest neighbor, and this oxygen will also share these 2 electrons of the nearest neighbor. As a result, they are sharing 2 pairs of electrons. This is one pair and this is the other pair. As a result, in case of oxygen, there are 2 covalent bonds. So this is the covalent molecule and these are the covalent bonds. Okay, now let us see one more example. Nitrogen. So nitrogen atomic number is 7, electronic configuration is 2.5. So it has a tendency to accept, it has a tendency to achieve 3 more electrons in its valence shell. So it can either accept 3 more electrons in its valence shell or it can share 3 electrons with some other species. So these 5 valence electrons are 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this nitrogen has a tendency to share these 3 electrons of its neighbor, and this nitrogen will also have a tendency to share these 3 electrons of the other nitrogen atom. As a result, it is sharing 3 pairs of electrons. So in case of nitrogen, 3 covalent bonds are formed, and this molecule is a covalent molecule. So the basic idea is, in case of covalent compounds, electrons are shared equally. This term equally is very important. So whatever electron this atom will share, this atom will also share exactly the same number of electrons. And in case of ionic compounds, the bond is formed by the transfer of electrons from one atom to the other. So let us discuss one question here. So the question is, which of the following substances contain covalent bonds? So these 4 options are given: MgCl2, H2, NaBr and CaO. So we will try to find out what are the type of bonds in each of these molecules. So let us see the first one, MgCl2. So magnesium atomic number is 12, electronic configuration is 282. So it has a tendency to donate these 2 electrons to some other species and achieve the nearest noble gas configuration of neon. In case of chlorine, atomic number is 17, electronic configuration is 287. So it will have a tendency to accept 1 electron in its valence shell. So how they will form a bond? Magnesium will donate these 2 electrons and it will form magnesium cation, Mg2+, because it is donating 2 electrons. And chlorine, it will have a tendency to accept 1 electron, but since here magnesium is donating 2 electrons, so to balance this we will require 2 chlorine atoms here. 2 chlorine atoms will accept 2 electrons which have been donated by magnesium, and it will form 2 chlorine anions. Now these 2 oppositely charged species will combine through ionic bond and form the compound MgCl2. So here we can see that electrons are being transferred from magnesium to chlorine. So the bond is ionic bond here. So in case of hydrogen, we have already discussed in the previous part that in case of hydrogen, electrons are shared. This hydrogen will share this electron, this will share this electron. So the bond formed is a covalent bond. In case of sodium bromide, let us check. Sodium electronic configuration is 281, so it will donate this one electron to some other species. Bromine, it is a halogen, so its valence electron will be like fluorine or chlorine. It will have 7 valence electrons. So sodium will donate this electron and bromine will accept this electron. So sodium donates this electron to form Na+, bromine accepts this electron to form Br-. So both these species will be joined through ionic bond to form NaBr. So here also electrons are being transferred from sodium to bromine. So the bond is again ionic bond. In the last example, CaO, calcium oxide, calcium atomic number is 20, configuration is 2882, oxygen is 2.6. So calcium has a tendency to donate these 2 electrons and oxygen has a tendency to accept 2 electrons in its valence shell. So calcium donates 2 electrons to form Ca2+, oxygen accepts these 2 electrons which have been donated by calcium and forms oxygen anion, and these 2 will be joined together to form a ionic compound. So these 3 compounds are ionic, and only this compound, hydrogen, this is a covalent bond, covalent molecule. So this is how you find out which of the bonds are ionic and which are covalent. So that's all about formation of compounds. Thank you all. Have a nice day. So this is one more question. Which of the following elements would form a covalent bond with Cl? Sodium, magnesium, potassium, carbon. So this question I have left for you to practice. Please try to find out what kinds of bonds will be formed between these elements and chlorine, and you can post your answers in the comment section. I'll reply to each of your answers in the next video. So if you like this video and you found it informative, please share my video and subscribe to my channel. Thank you all.